Hey, in this video I'm going to show you how to generate this pavilion. It's called Echinoidea and it was built in Italy 2022. I found the pictures with this pavilion on Pinterest and I found an article about the pavilion on Amazing Architecture. Show you the article and I will put the link to the article in the description below. This pavilion was designed by an architecture office, Gigi Loop, in Italy, and it's called Echinoidea. Echinoidea is a sea animal. If you go to Google and write Echinoidea, you will see this is that little sea animal that was the inspiration for this pavilion, this Swedish name for Echinoidea. What I like about this pavilion is that the architect didn't mimic the form. The form is stylized, and you see it's obvious that these protective sticks on this little sea animal correspond to this protective shell of the pavilion. After we generated the pavilion, I'm going to show you how to export the pavilion to Revit in order to make schedules and the production drawings for the pavilion. Here I have a PDF that I exported from Revit, and it's only half of the pavilion. And as you see here, there are 3 schedules for each row. The bottom row that I call row 1, the middle row that I call row 2, and the top row that I call row 3. And as you see, in Revit I could extract the cutting length of each stick. I could extract the position of every joint and the angles for every joint. And there are some additional measurements. I will explain them later. The next question is how to export the form generated in Grasshopper to Revit. The answer is today we can do that with help of a free plugin, RhinoInsideRevit. It was developed by McNeil. You install it in Revit and open it in Revit, and in order to use RhinoInsideRevit you have to have good knowledge in Grasshopper and good knowledge in Revit families. I cannot show more about RhinoInsideRevit because I'm working on Mac just now. Basically, you open RhinoInsideRevit from Revit and you have 3 windows open at the same time. It is interactive exchange of information between Rhino Grasshopper on one side and Revit on the other side. And thanks to this free plugin, you can utilize the best of Rhino and Grasshopper and the best of Revit. Revit is good for documentation and making schedules, and Rhino and Grasshopper are good for geometry. That's just a short explanation of the advantages of each program. Basically, what we are going to do is we will generate the curves, and then we will, with the help of perpendicular frames, generate the sticks. That's the basic algorithm. Generate the curves and then with help of perpendicular frames generate the sticks. I call them planks here. When we are done with half of the pavilion, then we will mirror that half, and there are some more things to do with this mirrored half. I will come to that later. And I just want to say something more about the perpendicular frames. Here we have perpendicular frames and I have to show them. The frames are infinite in size and they are going to cut through our curves. We are going to use those intersection points between perpendicular frames and curves in order to generate the sticks. And as I said, they are infinite in size and they are going to cut through all the curves that we generate. It doesn't matter how big they are on the screen. You can make them smaller or bigger, but they are going to cut through everything on the screen since they are infinite in size. I will show you how you can change the size of those planes as well. If you go to display and preview plane size, now I have 1000. We can add a 0 and press enter, and now you see how big those planes are. They're infinite in size anyway, it doesn't matter how big they are on the screen. I'm going back to change them, for instance, to 200. Enter. Now we don't see them. That's how you can change the size of the planes on the screen. They are always going to be infinite in size. As I said, we are going to generate the curves, and we are going to use graph mapper and parabola function. Instead of using curves and the intersection points between the curves and perpendicular frames, you can use also surface. You can cap surfaces with the planes, but there are always different ways to do the same thing. It's up to you how you want to do that. I'm going to use the curves. As I said, we are going to use those curves and perpendicular frames to generate intersection points. So